Okay. Number 1. Let's divide everything by -2. We're going to end up with y equals -3x plus 2. And now that it's in y equals mx plus b, it crosses at 2. And you could go down 1, 2, 3 over 1. And continue to go down 1, 2, 3 over 1. And you draw your line right through those. Wow, that's crooked. Sorry. Anyway, that's your line. Again, I want to jump around for the sake of time. How do we check number 3 if 0, 0 is a solution for this inequality? Plug it in, right? Plug in 0 for x, 0 for y. So let's say 0 plus 0. Is that less than or equal to 1? Yes. So you just put a yes right there. Okay, it's as easy as that. When I ask you to check if it's a solution, all you got to do is plug it in and see if it works. Let's jump to number 6. Of course, when you plug in, you probably should show your work. X is 2, y is 3. So instead of y, I want to put in the 3. And we still have the less than symbol. We have a -3/2 x, but we said x is 2, and it's plus 6. So it's really easy to multiply a fraction with a number, especially if it's the same as the denominator, because that'll simply cancel out. So what we really have here is a -3 plus 6. What's the -3 plus 6? 3. So we really have 3 is less than 3. What do we say about that? Is 3 less than 3? So we say no, it's not a solution. Okay. Now, we will learn right now how to graph systems of inequalities. But before that, let's review graphing inequalities, right? Which we did in chapter 2. So we should all know how to do this. Let's just jump through a couple of these. Where do we begin graphing this inequality? At 2. What do I do from that point? Down 3. 2 to the right. Thank you. And then you could continue to go down 3, 2 to the right. And what you ask yourself next is, will this this line be solid or will it be dotted? Dotted. If it has a solid line underneath your inequality, then it'll be a solid line. If it does not have a solid line, it cannot be a solid line. So it must be dotted. So let's put some dots. And now we need a shade. All right, how do we shade? Well, we have to remember this, guys. When we graph, we want to represent our answers. So if I test the point 0, 0, and if it works, that means it is an answer, which means I'd be shading everything down here. If it doesn't work, that means that none of these are answers, so I'd be shading in the other side because I want to represent my answers. So if I test the point 0 for y and 0 for x, anything times 0 is 0, plus 2 will be 2. So we have 0 is less than 2. What do you say? Is that a true statement or false statement? True. So 0, 0 does work, correct? So it is an answer. This guy is an answer. That means that all of my answers are down here. Okay. So let's shade in. Now check this out. I want you to practice shading like this. Just draw some lines straight from the graph of your line, okay, like that. I don't want you to get all crazy with the shading, and I'll explain why. Just draw some lines like that, okay? There is a shortcut to shading. Instead of plugging in 0 for x and 0 for y, if y is by itself, you could just look at this symbol, and if it says less than, since we have y by itself, where's less than on the y's? Is it up here or is it down here? Down here. So anytime you have y by itself, you could think of it as if it's less than, you're going to shade in below. If it's greater than, you're going to shade in above. So that's a shortcut. Make sense? Okay, so you could use that shortcut every time. So should we try another, or should we jump to these like more interesting ones? Okay, so let's look at number 4, for example. This one's interesting because it has a letter, a variable on one side and a number on the other. And these graphs produce either a horizontal line or a vertical line. If y is by itself, it'll be a horizontal line. If x is by itself, it's going to be a vertical line. So how do we graph this? We go to the x-axis, we go to 2. Now this is the only time that we go to the x-axis first, right? We always start with the b value, which is usually a y-intercept. You always start with the y-intercept first. But this is the only time, this rare case, where you go to the x-axis, you go to the 2, you put a dot there, and you do a dotted line, a dotted vertical line right through it. So again, this one's kind of interesting because y is not right here, it's x. So if it's x, then you're thinking about the x number line. You're not thinking of up and down like y. You're thinking of left and right with x, right? So right here it says x is greater than 2. Which way is greater than on the x number line? To the left or to the right? To the right, so you're going to be shading in the right side. And again, don't get crazy with the shading. Look, I'm just putting some lines from my line. Okay, and I'll explain why in a couple of minutes. Another way of doing it would be, again, to test the point 0, 0. Plug in 0 for x, 0 for y. There is no y. It would say 0 is greater than 2. That's false. This did not work. So obviously your answers are on the other side. So it's up to you if you want to use the shortcut using the symbol or actually plugging in 0, 0. Let's do one more and then we're good. How about number 6? Where does it cross the y-axis?
At 0.
0. Okay, the b value is 0. Y equals mx plus b. From there I go up 2 over 3. And I could use that pattern backwards to extend the line all the way through. This will be a solid line because the inequality has a solid line. So let me do a solid line like that. Put some arrows on it. Now I need to shade in either above this red solid line or below this red solid line. What's my shortcut say? Above or below? Above. It's a greater than symbol. Greater than is above. So let's just shade in above. And again, don't get crazy with the shading. Just do some lines from that line like that. And now you're finally going to see why I say don't get crazy with the shading. You see, a system of equations, when we graphed one line, that represented all the answers to one equation, and we graphed another line that represented all the answers to the other equation, and that point of intersection was the single point that both of them share, right? And that's why the point that they share is the answer to the system of equations. Now, right here, we're dealing with the system of inequalities, and we know that inequalities have areas, right? So the answer to a system of inequalities will be the area that they share, not the point that they share. Does that make sense? Kinda? Check this out. If you have different colored pens, right now is a good time to use them. Let's graph this top inequality in red. It crosses at 2. I go down 3 over 2. Continue to go down 3 over 2. You could use that pattern backwards, but you'll be off the graph. We should know that this is a dotted line, not a solid line. It's a dotted line, so let's put some dots between the dots. Now I need to shade either above or below this red dotted line. What do you guys say?
Below.
Below. It's a less than, so you're going to shade in below. Now again, don't get crazy with the shading. I'll explain why right now when I do the other one. See, here's the challenging part of this simple lesson today. You have to ignore what you just did, pretend it's not there, and go to the other one. And if you have a different colored pen, it'll help you, and graph it as if that red one wasn't there already. So let's ignore the red and let's just pretend it's a totally blank graph. It crosses at -1. That's my b value. And from the -1 right there, I'm going to rise 2 and run 1. So rise 1, 2, run 1, and put a blue dot right there. And continue to rise 2, run 1. Use that pattern backwards to extend it the other direction. And this blue line, it will be solid because it does have a solid line underneath it. So let's go with the solid line. Now I need to shade either one side of this blue line or the other side, either above this blue line or below this blue line. What do you say with the shortcut?
0.
Above or below? Below. The shortcut has a less than symbol, so it's below. Of course, you could be testing the point 0, 0 to see if it works. That way you know what to shade. But the shortcut is to simply look at the less than, which means below. So shade in the lower part of the blue line, the below part of the blue line. And again, don't get crazy. Notice that I'm just drawing lines from the blue line. Now, again, the answers to a system of inequalities is the common area, the area that they share, okay? The answer to a system of equations is that common point that they share, but right here we're dealing with areas, so the answer will be the common area that they share, which is this triangular piece right here. So if you have a highlighter or a third color pen, you would really shade this in. This is where you could go crazy on your shading, because this is what truly matters, guys. Now, on the midterm exam, I believe they're going to just show the triangle that has this piece being solid and this piece being dotted, and then they're going to show this really darkened in. They're not going to show, I don't believe, any of this or any of that. It's just going to be this triangular piece, solid on this side, dotted on this side. Okay. Okay, so let's flip this paper over and do a couple more examples. This is your homework right here, guys. This is your homework. You have time in class to finish this. Everyone should finish if you don't waste time right now. So again, it's all a question of, do you know y equals mx plus b? And if you have different colored pens, it'll really help you. All right. So I want to graph this top one in red. It crosses at 1. From there, I'm going to go down 1 over 1. Down 1 over 1, because my slope is negative 1 over 1. Use that same pattern backwards to extend it all the way through. I see that there's no solid line underneath it, so it's definitely not going to be a solid line. I'm just going to put dots between my dots. Now, I need a shade. Now, again, you could test the point 0, 0 if you want. Right here, 0, 0. So if you did plug in 0 for y and 0 for x, it'll say 0 is less than 1. Is 0 less than 1? Yes. So this point is an answer. So you would be shading everything that's on this side, right? Or the shortcut way, am I shading above this red dotted line or below this red dotted line? Oh, it's a less than. That means I'm going to shade in below. So I hope everybody understands how to shade. And again, don't get crazy with the shading until you have and identify your overlap piece. Okay, so now we're going to ignore everything in red and just focus on this one and graph it in blue. This one crosses at the y-axis at negative 2. From that point, I need to rise 3 and run 1. So 1, 2, 3, and run 1 and put a dot right here. And again, you're going to rise 3 and run 1. And this one will be a solid line because the inequality does have a solid line underneath it. So let's draw this line solid. Now I need to shade in either one side of this blue line or the other side of this blue line. I could use the shortcut. This says above or below? Above. So I'm going to shade in everything that's above the blue line, which should be right here. Or if this confuses you, the shortcut confuses you, you could always test the point 0, 0. You could plug in 0 for x. You could plug in 0 for y. It'll say 0 is greater than or equal to negative 2, and 0 is definitely greater than any negative number. So this 0, 0 does work, so I would shade in everything on this side of the blue line. So again, don't get crazy with your shading. Just go for like a nice simple shade from your line itself. That way you could clearly see where the lines crisscross, right? Right here it doesn't crisscross, right here it doesn't crisscross. It's right here. This is your overlap piece. This is what truly matters, okay? So if you have a different colored pen, maybe look what's here. I got a highlighter here. Just highlight that area right there where it's crisscrossed. It's that easy. It's a piece of cake, right? Number 2, or is that too easy? Should we move on? What do you think? Move on. Move on? Okay. How about, I definitely want to go over number 5. That one's interesting. Let's graph the top one in red and the bottom one in blue. So this one in red, how do I graph that? What kind of line is that going to be? Vertical, crossing the x-axis at 1. So here's 1. This is the only time you go to the x-axis first, right? Most of the time you go to the y-intercept value. But anyways, you go to the x-axis on this special case. It is vertical. Is this vertical line going to be solid or dotted? Dotted. Okay, so let's put a dotted line right through it. Okay, now we either need to shade in this side, the left side, or the right side. What do you say? You could test the point 0, 0, which is clearly on the left side. If you plug in a 0 for x and a 0 for y, but there is no y, so just 0 right here, it would say 0 is greater than 1. Is that true or false? False. 0 is not greater than 1. So this point does not work. It's not an answer. So where are my answers at? On the right side, right? Or you could have also said this. since we're talking about x's, x is greater than 1. Which way is greater than, to the left or to the right? Obviously to the right. So shade in the right side. And again, don't get crazy with the shading. The other equation, it's not in slope-intercept form yet. So, I should have said the other inequality. So let's get that y by itself by dividing by -2. Dividing by -2, there's really an invisible 1 in front of the x. And divide by a -2. My new slope-intercept form inequality is y is greater than or equal to. Notice that I flipped it. Why did I flip it? Because I divided by a negative. The slope is now -1/2 x with the +1 as the b value. So right there, it crosses at 1. And then I go down 1 over 2 and continue to go down 1 over 2. Use that pattern backwards to extend it all the way through my entire xy coordinate plane that's shown right there. And I do know that this one's going to be solid. So make sure you do a solid line. Now we need to shade in either above this blue solid line or below this blue solid line. And it's important that if you're using the shortcut, don't go to the original. Go to the one that we have, that we use to graph. So what would we say? Above or below? Above. So we're going to shade in above. Again, don't go crazy with the shading because we want to identify the overlap piece. And once you identify that overlap piece, then you could highlight it or really shade it in. So obviously we are shading in this part right here. Like so. Cool. So some of them you have to rearrange, get in y equals mx plus b form first, and then you could graph. Now there are a couple of special cases. Let's see. I think number 10 will be interesting. This one crosses the y-axis at -2. From that point, I go up 2 over 3. Use that pattern backwards. This is a solid line. Do I shade in above this red solid line or below this red solid line? Above, because it's a greater than symbol. So lightly shade in above. Now the other one, you have to get the y value by itself. So let's divide by 3, divide by 3, divide by 3. You'll have y is less than 2/3 x plus 1. This one crosses at 1. And you go up 2 over 1, 2, 3. And you use that pattern backwards. So you'd have a dot over here. This one's a dotted line because the inequality does not have a solid line underneath it. So it's a dotted line. So let's put some dots between our dots. And I either need to shade in above this blue dotted line or below this blue dotted line. What do you say? Below. Right? Of course, you could always test the point 0, 0, but the shortcut's the fastest way. So this is below. So you shade in below. And again, what's important? The overlap piece. So what you should highlight is simply what's between this right here. That's what you really need to shade in. I don't know, highlight it, shade it, whatever. Shade that piece in. So that one looked different. That's why I decided to go over that one. Here's another one that's interesting. This one's very interesting because when you graph this top one, crosses at -2 and you go up 1, 2, 3 over 1, up 1, 2, 3 over 1. This will be a dotted line. And what side do I shade in? Above this red dotted line or below this red dotted line? Emma, what do you say? Above or below? Below. Less than is below. Okay, so let's shade in below. Again, don't get crazy with the shading. Just draw some lines from that red dotted line. Okay, now the other one we're going to graph in blue. That one crosses at 1. I go up 1, 2, 3 over 1. Use that pattern backwards. 1, 2, 3 over 1. And this is a solid line. And are we going to be shading in above this blue solid line or below this blue solid line? What do you say? Above, because it's greater than. So let's shade in above. Don't go crazy because we want to really represent the overlap piece. Now what's the problem here? They don't overlap. So what's the appropriate response or the appropriate answer that you want to say for this system of inequalities? Exactly, no solution. Perfect. No solution. Okay. I mean, after all, the overlap is the solution. If there is no overlap, then there's no solution. See, what it means is if I were to pick any coordinate in here, like the coordinate 1, 1, that's inside my shaded area, that would work. If I plug in a 1 for x and a 1 for y, it'll work. If I plug in a 1 for x and a 1 for y, it'll work. Any coordinate in here will work. So if I'm trying to find those points that work for both, and there is no overlap piece, there is going to be no answers. So you put no solution. Anyways, I did almost half of your work. You guys could work on the rest right now in class. The answers are provided on Edmodo as a colored PDF. So you guys could actually see the different colors. It's a lot nicer than what I have back here. Back here I have a black and white copy of the answers. So that's kind of confusing. But you could take a picture of that with your cell phone if you want to be looking at your answers right now in class. But on Edmodo you have the color version of the answers. So I recommend you guys get on there to check your answers.